Hello and welcome back to Calculus 1 with 3. So if you remember last time we looked at graphing equations and functions, and today we'll examine a few types of equations more closely and see what happens when we move some graphs around. So the first thing we're going to start with are lines, which are very simple objects that turn out to be very useful. And because they're so easy to work with, much of calculus was actually developed based upon them, and we actually use them to approximate more complicated nonlinear things with a succession of smaller and smaller lines. So if we have a line, what information do we need to know about it to graph it? So if we look at a line, it can have a bunch of different directions. Starting from this same point here, they all have different directions. These are all different lines. And say we know a direction like this, we have to figure out where it is in space, and to know its position, which we can find from a point on the line, or a set of points on the line, or some other information. And it can be up and down, left or right, whatever. So the most common way to express the direction of the line is the concept of the slope. So let's draw a line here. Something like this. Okay. And this tells us if we go some distance in the x direction, let's call that a delta x for a change in x. There's a corresponding change in the y direction due to the direction of the line. We'll call that delta y. And the slope is simply the ratio of the change in y to the change in x, and we usually denote that by the letter m. Say m equals delta y over delta x. Okay? So once we know this slope, let's say we know a point on the line. Let's call this point here, I don't know, x naught, y naught. Okay? And pick some arbitrary point on the line anywhere. Let's call it xy. We want to know how to write this line in some simple form. So we know this equation here, m equals delta y over delta x. But what's delta y and what's delta x? Well, if we have these 2 points, delta y is y minus our point we know, y naught. And delta x is whatever x point we have minus the one we know, x naught, right here. So if we substitute these into this equation, we get m equals y minus y naught over x minus x naught. And multiplying the denominator to the other side, we get y minus y naught equals m times x minus x naught. And you might recognize this as the point slope form of a line. And that's because we have the slope here, m, and a point, y naught, x naught, which we had up here. One special case of this is when the point we start with is on the y-axis, right here. This means the x-coordinate is 0, which simplifies this a little bit. And we get y minus y naught equals mx. And this is usually written like y equals mx plus b, where this b value is the intercept on the y-axis. Wherever x is 0, we get this value of b. And that's why this is usually called the slope-intercept form of a line. Okay? And both of these equations can be rewritten in what's called the standard form, which is less useful, but it's more complete in that it accommodates vertical lines which have an undefined slope since they go straight up. And that's this form, ax plus by equals c. And that accommodates things like x equals 4, which has an undefined slope. And although this form is typically much less convenient to work with, and when we're doing math, we usually, if we're given a line in this form, we usually convert it to one of the other forms first. So let's try and graph a line. Let's say this line L goes through the points, I don't know, 1, 3, and how about -1, -1? Okay? So the first thing we need to know is to compute the slope, since we already have some points. So m is going to be delta y over delta x. And what's that? Let's say we have these 2 points. And since the line is straight, like this, it doesn't matter what 2 points we pick. We can use any 2 and we'll get the same slope. So let's use the 2 we have and do -1, -3 over -1, -1. And that equals -4 over -2, which is 2. So the slope of our line is 2. And then we can use the point slope form and plug our point in, and we'll get something like y minus 3 equals 2 times parentheses x minus 1. And that's a perfectly good equation for our line.